I'm Sam Inman. This is my presentation on nanotechnology and the future of wireless communication. It's going to extend my timeline on wireless communication, which I think will be extended through the study of photonics and technology of photonics. So, what is nanotechnology? Nanotechnology are materials and devices that are made so small that they're measured on the same scale as atoms. They're not as small as atoms. They're not smaller than atoms, but they can be hundreds, thousands, sometimes smaller than hundreds of atoms wide. So they're measured in nanometers. These are carbon nanotubes. I think they're really interesting. They're used for different things like microscopy. They're just carbon in a hexagon pattern. Yeah, used for different light absorption. They absorb a lot of light. Um, yeah, they're cool. What is nanoscience? It's the study of the nanoscale itself, understanding how are the forces on the nanoscale. What are the forces doing? How can we interact with the forces and different different technologies that can come out of the quantum properties at the nanoscale. Why is nanotechnology unique? Well, they exhibit unique properties because they have a larger surface area in their surface to volume ratio. So as things get smaller, the surface area will remain a little bit larger in the surface to volume ratio. It's hard to understand, but it leaves more space for things like chemical reactions and different surface based interactions. Uh, Other unique effects can occur, like quantum property, electricity, magnetism. So at this small scale, this is where these forces are stemming from. So a lot of cool things can happen, like plasmonics. Uh, Plasmonics it studies plasmons, which are the in sync oscillations of electrons. So it's like an electron wave on the surface of a metal, and when a photon comes in and hits these plasmons, which are like just electron waves on metal, the photons can couple to the electrons and form surface plasmon polartons, which is uh, being studied in photonics. And there's different technologies that come out of surface plasmon polartons, like waveguides, make plasmonic waveguides, which I'll mention later. Nanotechnology today, it's a vast field of science, and some applications might include improving electronics and photonic integrated circuits, where we can improve existing technologies, make more lightweight devices, get more efficient data transmission, less energy loss. We can improve things like solar panels through all different photonic and nanotech and photonic tech. So I think that's promising for the solar panel world, and even things like water filtration we can improve. Um, different things like that, like water filtration. This is graphene, diagram of graphene. This is a quantum computer. These are solar panels, which I think nanotech will really improve solar panels, because we can make these better. It's destined to happen. Uh, Photonic integrated circuits. We talked about nanotech, so let's talk about photonics. It's the use of photons to transmit information, whereas electronics uses electrons, of course. Now, photonics will save energy compared to standard electronics because it, for the most part, eliminates the use of copper wire, where copper wire has heat loss, right? It has heat loss, so we can save that energy and natural resource. I think photonics is is going to be really important in the future. I mean, a lot we have a lot of photons as of right now, and I think we can make good use of them. And you could argue, well, we got electrons all around us too. We got a good amount of electrons, but I think that's an arguable. I think that's arguable because I think it takes more energy to use electrons for electricity, and I think we can make better energy conversion processes for light to energy. I think that's a possibility. So how will nanotech improve wireless communication? Well, just a reminder what nanotechnology really is. It allows us to use the forces of nature, like light, electricity, to act upon quantum properties themselves, like electrons and chemical reactions. So, for example, we can use light to interact with electrons, make surface plasma and polartons. We can use electricity to react with chemical reactions. That, I guess, would be electrolysis, but maybe on the nanoscale, it could be different. There could be a lot of things that we haven't done yet, because nanotech is a new field. So what can we improve through things on the very small scale? Well, there might be a lot of things. Maybe nano antennas. I mean, right now we have these giant antennas in our skies. Could we make these smaller? I think so. We saw it happen from the 90s with cell phones to today. The antenna on the cell phones, it got smaller and smaller. If we want to exponentially increase our efficiency and our size, then the nanoscale might be the way to go. And nano antennas are still being researched, so we can see how photonics might improve these antennas and wireless communication. There's plenty of room at the bottom. How do we minimize energy? That's the goal. How do we minimize energy demand through photonics in the future? It might look like having on-chip plasmonic waveguides where they consume less power, allows higher frequency ranges. Same thing with nano antennas. They also consume less power and operate at higher frequencies, which can allow for more efficient data transmission and hopefully more efficiency overall. On nanoplasmonic solar cells. Now, our solar panels might be drastically improved through nanophotonics. We can trap and absorb more light and minimize energy loss through our solar panels, which I think those are the major hurdles in solar energy. So this is how I think that photonics can improve wireless communication in the future. Thank you.